Good morning, everyone. I'm assuming it's morning. If you're in a different time zone, maybe it's a different time of the day. Here in Europe, at least, it's still morning. Today, we're gonna do a mostly live demo session about Podman and Podman Desktop, and we're gonna, kind of see how we can go from our local development to containers, and then further on to Kubernetes. And then at the end of the session, we'll also take a look at some new features in Podman Desktop to work with AI models. So stay tuned, and hopefully you'll enjoy it. So my name is Kevin Dubois. I'm a developer advocate at Red Hat, and I'm based in Belgium. And yeah, I'm also a Java champion, so that's why you'll see that I'll play around with a Java application. But the idea is that it doesn't necessarily matter what stack you work with, whether it's Java or .NET or Node.js or Python or Go or whatever. The same kind of principles should apply, right? But so I'll use a Java application that I'll containerize. And yeah, apologies if my voice is a little crackling. I'm a little cold, so good thing this is a virtual session, right? But yeah, so let's go into it. So why should you care about Podman, right? What is the goal of Podman, and why are people interested in Podman? Let's start with that. So on the one hand, we've seen that quite a few people are looking into Podman because of the license change of Docker. Some organizations, they want to run containers in a rootless way, which is a little more complicated to do with Docker, and it kind of is the default with Podman. Maybe you don't need Kubernetes. You just want to run one or two containers in a small environment or something. Then you might not need Kubernetes, but you do want to run it in a Linux environment. Podman is actually really great for that as well. Maybe you want to learn about Kubernetes, and you want to start from containers and go from there. That's also a great use case. Maybe you want to manage multiple container engines, like you have Docker engine and Podman engine and maybe Lima or whatever. You can actually use all of them with Podman Desktop. And like the best part about it, in my opinion, is that it's completely open source and free, right? So that's that's always great. So let's take a look first in Podman. So let's so we have Podman and Podman Desktop. So Podman is basically the project to run containers, to manage containers on a machine, right? And the logo of Podman and Podman Desktop is very cute. There are these little seals. So I did want to share that first. And the idea with a group of seals, just like with Docker, you have whales and a group of whales. And with seals, a group of seals is a pod, so that makes sense, right? So for Podman Desktop. So Podman is a fast and lightweight way to run containers in a daemonless way, right? So with Docker, you have to have a daemon running at all times, which is going to manage the containers. With Podman, you don't need a daemon. It's just system processes. Podman, like I said, is open source first, and so you're not going to get logged in because it's just an open source project. It's by default rootless. So in terms of security, that's a first kind of a primary concern, and it's compatible, of course, with other container build environments. So if you've built your container with, for example, Docker, you can use it with Podman just the same, right? So they're all OCI compliant, so the Open Container Initiative compliant. So let's look maybe real quick into Podman. If you're familiar with Docker, this would be very kind of straightforward because the commands are very similar, right? Or virtually the same. There's maybe some differences in terms of Podman can do different things as well. But to manage containers, to run containers, to build containers, you're going to use the same commands that you do with Docker, right? So you can do podman run, podman create, podman build, and so on, podman push. But in addition, with podman, you can actually also create pods, which is a group of containers running in the same kind of network and using the shared resources, just like you would in a Kubernetes pods, but just in a small containerized environment. In addition to those kinds of commands, Podman also supports Compose. So if you're familiar with Docker Compose, it is also able. You're also able to run those Docker Compose files with Podman. So you can do Podman Compose up, Podman Compose list. So the same kind of commands that you use with Docker Compose. If you need to expose the kind of a Docker socket. So for example, if you're working with test containers or something, you can actually bind the socket as well. And you can also, if you're wanting to use some more advanced features such as WASM with WebAssembly, that's also supported with Podman. So the container philosophy of Red Hat basically is to give you the tools that you need to get the job done for a specific use case, right? So Podman is a CLI and a container engine to run and manage containers, and then you have different kinds of projects to do different things. So you have Podman Desktop, which is a UI environment that we'll look into for most of our session today as well. You have, for example, Builda to specifically build containers in a few different ways. Scopio to interact with container registries, crun, and so on and so forth. So, you'll see that Red Hat is involved in many of these projects. And then one interesting feature that has been added in Podman recently as well is a way to integrate with systemd, so you can actually run containers with systemd and then integrate them with your kind of production workloads where you don't necessarily want to manage containers in a separate way. So that's something interesting as well if you're interested in that. And then there's Podman Desktop as well, which is our UI component that we'll look in just a minute. So before I move on to that, maybe we'll start with a very simple kind of demo here. So I'll just show you that Podman is kind of very similar to work with as Docker if you've used Docker before. So you can do Podman, for example, Podman image list, right? So to list the images that you have, and you'll see that I have quite a few on my local machine, and you can do Podman or Podman run to run a container image, and so on and so forth, right? So those are very simple commands to get started with containers, and of course Podman build to build a container image. So you could supply a container file, a Docker file, and then build your container image from there. I'm not going to go into too much detail with the CLI today. I'll mostly demo Open or Podman Desktop. But if you would like to see more of the CLI, let me know in the chat, and then we can revisit that at the end of the session as well. All right, so I'm going to go back to the slides here for a second, and then we'll quickly get into more of the demo parts here. So Podman Desktop, the idea is to give an kind of an easy way for developers to move from containers, to work with containers, integrate them maybe with compose files, maybe create pods from them, and then to also integrate them with Kubernetes environments, because that's for the most part where our containers are going to go when they go to production, right? I mean, again, you can run Podman in production as well, like for example in edge environments where you need very small deployments. You don't necessarily want to have an OpenShift / Kubernetes environment. But for most of us, it does end up going to Kubernetes these days, right? So Podman Desktop tries to kind of bridge the gap between like local containers and then going to those Kubernetes environments. So that's it. Let's go into the demos, and then everything hopefully will be a little more clear. So I'm going to start up Podman Desktop here. I'll start here with the dashboard, and you'll see that in my case I have a Podman engine already running. So if you are new to Podman Desktop, you would go perhaps to podmandesktop.io. So you can go here, desktop.io, and then you can download it for your environment. So it is supported for Linux, for Windows, and for Mac. In my case, I'm running it on Windows, but so if you have a different environment, that works as well, right? So you can see on the Podman Desktop website that you can go to downloads, and then you can install it the way that you would like. So if you are on Mac and you want to install it with Brew, or with Windows and you want to use Winget, or you just want to install it in a different way, or maybe on Linux you use Flatpak. So there's many different ways that you can get started. And then Podman Desktop will guide you through setting up your environment. So for example, on Windows, it'll guide you through setting up a Podman machine with Podman engine, and so on and so forth, and on Mac as well. On Linux, you don't need a Podman machine, because basically these Podman machines are virtual environments, virtual Linux environments. And since we're on Linux, we don't need that in my case. So once installed, you'll see this, right? The Podman Desktop with our dashboard, and you'll see that in my case I'm running Podman version 5.11. If you are familiar with OpenShift, there's a free kind of OpenShift environment that I'll show in a little bit too, which is a developer sandbox. And you can see that it's recognized that I am already logged into this developer sandbox, and it says it's running. If you want to run a Kubernetes environment on your local machine, that is perfectly possible as well. And Kubernetes or Podman Desktop gives you quite a few ways to do that. So in this case, you can see that I have OpenShift local installed on my local machine, and yes, I am a few versions behind, so I should probably update. But you can see that if I wanted to run it, I could run it directly here from Podman Desktop as well, and it'll guide me through the installation. Then you can see there's also this learning center with links to some articles to also get started, and maybe some shameless self-promotion here. Managing Java containers with Quarkus. So for example, if you go to that one, you'll see that it links to an article that is written by this guy, Kevin Dubois. That's me. Anyway, so you'll see different resources to get started with Podman Desktop as well. And so that's our dashboard. Then, of course, most of the core functionality is, of course, running containers, right? So you can see that we have a containers view here. I'll make it slightly bigger so you can see it well. In this case, I don't have very many containers, so I just have this one container that stopped. You can run pods. You can access the images, volumes, just as you would expect, right, from a container environment. And then you can also extend the capabilities of Podman Desktop with a bunch of extensions. So you can see here that I have extensions for example, bootable container. And this one's an interesting one. So you can actually create a bootable environment from a container, which means that you can create an ISO or different ways to start up a container as kind of a native environment on a Linux environment. So that's a pretty cool one. And then so for example, here we have a compose extension, and for these extensions, it'll also try to guide you through installations and everything. So you can see here there's a compose extension, yes, even a Docker extension. So you can run Podman Desktop and then have Docker running underneath as your engine. Or you can, for example, install local Kubernetes environment. So I already showed you how you can do OpenShift local. In this case, you can also, for example, install Kubernetes in Docker, so kind cluster, and so on and so forth. You can also use Podman Desktop to interact with remote clusters, right? So you can see here that there's these extensions to switch Kubernetes context. So if you're logged into multiple Kubernetes clusters, you can switch between them very easily. So here at the bottom left, you can see that I have a few environments here, and I can switch between them just by clicking them. And then my context would be set to point to that particular Kubernetes environment, which is a little bit handy, right? And you can see that you can have kubectl CLI extension, so it'll guide you through the installation of kubectl, et cetera, et cetera. Now let's dive into the settings real quick, and then we'll start creating our container images. So here in the settings, you can see that we have, in my case, Podman, the Podman engine, right? So the engine that actually manages and runs the containers, and it's exposed on this endpoint as well. I don't have my OpenShift local running at the moment. My kubectl here. I could create a new kind cluster. I could create new developer sandbox environments, and so on and so forth. If you are in a corporate environment and you have proxies, well, of course, you can set those here as well. You can log into different registries from Podman Desktop. You can authenticate with different authentication providers. And then here's the CLI tools, which I find pretty handy. So if you are needing to interact with Kubernetes clusters, you'll most likely need kubectl or maybe the OC CLI command. You can install it straight from here, and you can see that there's a newer version of kubectl available. So maybe I can even update, and it'll help me to update my kubectl environment, and same with Docker Compose. And yeah, and here we can see our Kubernetes cluster. Oh, I need to authenticate, of course. Let's do that real quick. There we go. And so that's, a very quick overview of, Podman Desktop in terms of our preferences. So let's start with a container image, right? So I'll start with an application here. So I have a very small Quarkus application. So if you're not familiar with Quarkus, it's basically a Java stack that starts up really fast, uses less resources, and has a lot of convenience features to interact, with containers and Kubernetes. But in this case, I'm not going to necessarily use those cool Quarkus features. I'm going to, try to use Podman Desktop, of course. But you can see here, I just have a few applications. Basically, this application shows how many, has a Redis backend. And so it has a caching to keep track of how many times I visited a page. So I can run this on my local machine, and we can start with that. So I can use, for example, the Quarkus dev mode. And what that does is start up a local environment, and it'll notice that I don't have a Redis container running on my local machine. So I'm going to go here. You can see here in our containers in Podman Desktop, there's no running containers right now, right? But I do need a Redis database for my application. So what Quarkus is going to do is leverage this project test containers, even when I'm developing, and start up this container to help me during my development, right? So you can see that two containers just popped up. So one is test containers Ryuk, and the other one's library Redis 7. So because I didn't have that dependency, then Quarkus started that up for me, and you can see that Docker or Podman Desktop picked up those containers, And now my application started up using those containers. So we can see here that our application is running on localhost 8080. Let's go and take a look and see if that's actually running. And yes, we can see that. Hello, this website has been viewed 1 time. And then if I hit refresh, we can see that 3, 4, 5, and so on and so forth. No, very exciting websites here. But, so this number is basically being saved in our Redis backend. So that's cool. My application, let's say that I developed it, and now I'm ready to start containerizing it. So I'm going to stop my local development here. And then, with a Java application, what we would want to do is package it up, right? So we can do, for example, Maven package, and then I'll skip the tests for now, if I can type it correctly, so we can move a little bit faster. And then we can see that in a few seconds, we'll have packaged up our application that we can then containerize. So when you create a Quarkus application, it actually supplies a few Docker files, so container files, in your source main Docker folder here. So you can see that there's a Docker file JVM, there's a Docker file legacy, native, and micro. So in this case, I just built my application as a regular Java application, so I would need a JVM. So I'm going to use this dockerfile.jvm. If I had compiled it down to a native binary, then I would use a different container file, which would end up with a much smaller container image. But in this case, this is kind of the fastest for my demo, so I'm going to use this. So if you're familiar with container files and Docker files, you'll see that this is fairly straightforward, right? So it's just a plain Docker file where you have a from, and the from is where your container, what you're building on top of. So I'm using a base image, in this case, UBI, so universal base image that's been tested and verified by Red Hat. Those are also free to distribute with OpenJDK 21. And then I'm copying my artifacts into this container image. I tell the container that I'll want to expose port 8080, and then basically how to start up the application. So let's build this container image from Podman desktop. So let's go back to Podman desktop. I'll go to my images tab here on the left, and then to the right here, you can see that there's a build image. And so here I can find the container file, right? So I'll browse to my workspace, and I have to remember where this is. So I think it's in the Red Hat developer demos, and then Podify Quarkus Redis, if I'm not mistaken, and then source main Docker file JVM, right? That was the one that we were looking at. So I'll select that. Now the build context is where basically it's the root path for everything that the Docker file, the container file, is looking at. And that is, of course, not in the source main Docker folder. It's in the main application, right? So Podify Quarkus Redis. Then I can give my image a name. So we'll call this Quarkus Redis. I don't know. I don't have much inspiration today. And then I could add some build arguments. Now, what's interesting is that I could build this image for my local environment, which is running on an Intel hardware. But if you want to target a different architecture, you could target ARM, Power. Even you could create a WASM container image from here too. But in this case, I'm just going to target my Intel architecture and click build. So by doing the build, we're going to create our container image, which I believe I've called Quarkus Redis. Yes, so we can see that successfully built and tagged our image with Quarkus Redis. So now if we go to our list of images, we can see that here, 13 seconds ago, we created this Quarkus Redis image. And, so now we can do a few things with it. So we could directly push it to a registry. I could edit the image name, which is a little handy, right? So especially if you're going to push it to different registries, you can just change the name here. Let's say maybe I'd want to push it to docker.io. Then I just re-tag it, or maybe I want to tag it with a different name. Anyway, so in this case, I'm happy with this name. And you could, for example, see the history of the build. So you can see all the different steps that our image build went through to build our container image, which is pretty handy if you need to kind of debug and see, like, well, my image build did something weird. Let's see exactly where it went to find these files and how it did everything. And so that's pretty handy. You can inspect your image manifest, and then you can also check your image analysis, which, yeah, for some reason that's not working right now, so we'll just ignore that. But in theory, at least, the image check would also scan your image for vulnerabilities. And like I said, then you can push your image to, for example, if you're running Kubernetes in Docker cluster on your local machine, you push it from here. If you want to push it directly to a developer sandbox or to your OpenShift local cluster, you could do that as well. In my case, what I'm going to do is I want to start this application running on my local machine. So I'm going to hit this play button here in the top right, and then give the container a name. If you don't do that, that's fine too. It'll just create some random name. I'll call it Quarkus Redis again. And as you can see here, this port mapping maps my port and exposes it on my local machine to port 8080 automatically, which is something that I really like about Podman Desktop as well. Is if I had already something running on port 8080, then it would actually map it and set, for example, port 8081 here. So it's smart enough to figure out, like, hey, the container is trying to expose port 8080, but we can't actually map it on your host on that port because it's already taken. But in this case, we're good. Port 8080. We could add some environment variables and environment files and whatever more. Let's see. Do I need to do that? I don't think so. So we'll see how that goes. So I'm going to start the container. Okay, now we go and see that our application, our Quarkus application, has started up correctly in less than a second, running on the JVM. So that's not too bad. Now I'm going to have probably an issue though. So let's take a look and see how this application is going. So here in the top right, there's an open browser. So based on the port that's exposed, it knows that on your local host, it should be running on the exposed port. So I'm going to click on that, and we can see, oops, there's an error, right? And I can see it in my browser as well. Of course, that's expected, right? Because we're trying to call our Redis backend, but now we're not running in this Quarkus dev mode where it starts up a test container automatically. I do have to actually have a Redis caching database running, right? So that's why it's saying connection refused, because it cannot find that. So fortunately, I do have that container image. So let's find it real quick. So I have this Podify demo backend, which is a kind of a silly name. But it is the Redis caching database. So I'm going to start that one up as well. So I'm going to run image here, and let's call this Redis. And I don't need to do any port mapping because I just want to have this available internally. And I'm going to start my container. Okay, so now I have my Quarkus application running and my Redis database. Now, let's try it again, but we still have an error, right? So the thing with containers is that if you run them, their local network is only available in their local context, right? So what you would need to do in, like in a Docker environment or in a traditional Podman environment, is that you would need to create a container network, then add both these containers to this network, and that's how they could share their networking resources. So there's a few ways you could do this, right? So you could do this manually. With Docker Compose, you can actually create a Docker Compose file and then add them to the same network as well. So I can show you that this is a possibility, right? So I have a Docker Compose file here, and we can see that there's a Redis service that points to my image that has, I set the container name, I set the ports, and blah, 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 and then networks, Quarkus network, and then I have a Quarkus application, and so on and so forth. So, this would work, and, we can try it even. So I can do Podman compose up. And, well, I need to stop my running containers because they're trying to use the same port, because Podman or Docker Compose is not smart enough to figure out that, hey, wait, you're trying to expose them on the same port. So I'll go ahead and delete these two for just a second, just to show you Podman Compose and Docker Compose. So now I started that up, and both these containers are now running in the same network based on this Docker Compose file, right? And you can see that here in a Podman desktop, it is also able to see Compose environment. So you can see here this environment Compose with both our services. Now, if I go to my localhost 8080 again and I hit refresh, we can see that it is working again, right? Because they're sharing the network. Now, for me personally, Docker Compose files are okay, but they're a little bit tedious to set up. And the problem is that afterwards, once you want to go to a Kubernetes environment, that construct of Docker Compose doesn't really work, right? Because in Kubernetes, we want to use pods, and we want to use deployments and services, which is a different kind of definition. So now we have to learn this, and then we have to use a whole different construct for Kubernetes. So there's a few different ways that we can use Podman and Podman Desktop to do this in a more Kubernetes native way, if you will, or at least in a way that that we're familiar with, that we can transpose to Kubernetes. So we can see here that we're stopping this service, this compose service, and if it's not hanging, we'll see that in a second. It'll stop. And I'm going to go back to my containers. Let's delete it from here, maybe. See how that goes. Okay. So I'm going to go back to my images. So I'll find my backend service again. I'm going to start that up again. Up. Make it a little bit smaller. There we go. That's too small. Make it a little bit bigger. There we go. Start container. So now I'm starting up my Redis environment again, and I'm going to start my Quarkus Redis environment again. There we go. Now we have both containers running. So now what I'm going to do is I'm going to select both of these containers, and I'm going to say create pod. And so if you're familiar with Kubernetes and pods, or maybe you're not, but the idea with a pod is that you create a single deployable unit that contains maybe one container or multiple containers, and they share the same resources. So what would happen here is that they would share the same network by default. So that's what I'm going to try to do with create pod. That should allow me for the application to point my local Quarkus application that's running in a container, pointing to local host, right? Because I have it configured here in my application properties. Quarkus Redis host is pointing to localhost 6379. So it's looking for localhost 6379. And since they're running in the same pod, that localhost would resolve. So let's make sure that that's the case, right? So we can see here that we have the pod running with our Podman desktop, Podify demo backend, and the Quarkus Redis. So let's go now to our environment here, and we can see that, yes, it is running again, right? Well, we could see it for a second, and there was a little bit of lag on my local machine, but we can see that that it's working, right? So I didn't have to create any Docker Compose files in this case. I didn't have to configure anything. It's pretty handy that you can just do it in the Podman desktop UI, right? So that's one way that you could work with pods on your local machine. Now there's a few different things that you can still do in Podman desktop. So you could do, for example, play Kubernetes YAMLs. So you could apply YAMLs, and then, for example, you have a YAML of a pod, you can actually play it, and it would also deploy and create pods on your local machine. So in this case, you can also see that there's this Redis, blah, 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 with some tags and IP, la, la, la. And it says environment Kubernetes. So I can also see my pods that are running in a Kubernetes environment that I'm connected to. So that's what you can see here at the bottom. So I'm going to go ahead and stop my pod for a second. Up right here, stop. And let's take a look at how we can now get from this environment to a Kubernetes environment. So I'm going to go to developers.redhat.com. And up here, you can see there's Developer Sandbox. So this is a free environment. So if you have a Kubernetes environment, you can use that one. But if you don't, this is a nice way to get started with OpenShift and Kubernetes. And then you can see start your sandbox for free. And then you'd have to log in, of course. And then on the next page, see if the internet wants to collaborate. We'll give it just a second. That we'll see the OpenShift environment. In the meantime, if you have any questions, make sure that you post them. I'll answer them at the end of the session. All right, so here we can see Red Hat Developer Sandbox. So we can see Red Hat OpenShift. This is the OpenShift environment that you can launch. You can also launch a dev space, which is an IDE running in the cloud, so based on VS Code or IntelliJ. Or if you want to play around with some AI stuff, you can also start an OpenShift AI from here. But anyway, in this case, just want to do an OpenShift environment. And once I'm logged in, we'll see that I am in my project, Kevin Dubois Dev. And if I go to the developer view, we can see that I've already deployed a Redis backend, but I need to deploy my Quarkus application, right? So there's a few ways that you can do that with Podman Desktop. So one of them is you can push your container image and then deploy it from the OpenShift UI. You can apply YAMLs. You can also deploy your application directly from Podman Desktop as well. So you could say generate Kubernetes files and then apply them, or you can deploy directly to Kubernetes. So in my case, I'm going to do a slightly more traditional way. I'm going to just say, hey, push my container image to Quay.io. And if it wants to collaborate, I'm having a little bit like machine. So I'll try that again. Sorry for that. All right, so push image. And so we can see that it's trying to push it to Quay.io, Red Hat Developer, Quarkus, Redis latest. So that's an environment that I'm logged into because I logged into the registry in the settings, right? So you can see here the push refers to blah, blah, blah. And so we pushed our container image to the Quay registry. And we can even go look at that. So if we go to Quay.io and we go to Red Hat developers and we search for Quarkus Redis, we can see that, last modified 10:40 a.m., right? So we just pushed this image, and it's basically available for us to deploy now. I'm going to just make sure that we have it available publicly, which we do. Okay, so now I can go to my developer sandbox. If I can find the right tab, here we go. And click on add here, and select container image, and then quay.io/Kevin Dubois, or sorry, Red Hat developers /Quarkus Redis. So that's the image that I just pushed with Podman desktop, and it's gone very slowly. There we go. And I just tagged it with latest in this case, so very simple. Let's give it a nice Quarkus runtime icon. And then we'll deploy it as a serverless deployment. That's fine. And then let's see if that works. I need to do one more thing, which is add an environment variable, right? Because if I go back to my application, we can see that I need to set Redis to the service name, right? Because localhost is not going to work on a Kubernetes environment. It's going to be the name of the service of Redis, which I believe I called Redis. So we'll see if that's true. Okay, we'll create it, and hopefully everything will go well. And then here we go. So now the pod is being created as a serverless application in this case, and then hopefully in a moment we'll see that that it's up and running. Okay, we can look at the deployment. We see that there's a pod running. Let's take a look at the logs. Well, there's nothing in the logs. That's okay. We'll just go look and see if the application is up and running, right? So everything is a little bit slow on my local machine. Sorry about that. And hopefully you can hear me fine. In the meantime, our application is running. So we'll open the URL, and we can see, yes, it is working. And we can hit refresh, and we can see that I've called this 3 times. So it is connected with our Redis backend, right? So in theory, if I now kill this pod, it should create a new pod. And because we have the Redis backend, see, it's creating a new container. And we should pick up from where we left off, which was 3 times that I've called it, right? So we'll see if that's the case. So I'm going to go back to my application, open URL, and we can see, yep, 4. So, our caching is working and everything is going well. We've deployed our application to production. And we did, most of the work here from Podman desktop. Now, there's a few more interesting bits and pieces about Podman desktop. So this was, to kind of show you how to work with images and containers and pods. You can see that if you're logged into Kubernetes, you also have this view. If you have the Kubernetes extension in Podman desktop, you can see here on the left, there's I can see which nodes I'd be logged into. Looks like I need to make sure that I'm in the right context, which, let's try this one. Okay, here we go. And we can see also our Kubernetes resources straight from our Podman desktop, right? So I can see here the Kubernetes services that are running on this sandbox environment. We can see the deployments that I've created. And we can see, if I had any persistent volume claims, we'd see those as well. And routes that would be exposed and everything. So we could see that all from Podman desktop as well. So we can have a nice interaction with the Kubernetes cluster, and we can even apply YAMLs directly from Podman desktop. Now, let's switch gears and look at some of the new extensions here in Podman desktop. So the extensions, again, you can see them here, right? So there's a catalog of extensions, and if you know of any Docker desktop extensions, you can also just install them from here. So they should be compatible with Podman desktop as well. So we can see here that I already have installed Podman AI Lab. So everybody's talking about AI these days. So like we might as well explore that a little bit ourselves as well. And so this Podman AI Lab is right here. I've already have it installed. And once you install an extension, you can see it here on the left. And this AI Lab basically allows you to run models, AI models on your machine. So in this case, we have quite a few already as models that I could download and then deploy. If you want to deploy your own model in the GGUF format, you can also just import them yourself. If you want to go to Hugging Face and find a model that you like and you want to run it, you can do that as well. So in this case, I've already downloaded the InstructLab Granite model. So InstructLab and Granite. So Granite is an LLM, an open source large language model. And then InstructLab is a way to, it's an open source project that allows you to basically add more skills and knowledge to models and contribute them as well. You can train them on your local machine and everything. It's kind of a sidetrack, but it's a really, really cool project if you haven't looked at it. So in this case, this is the model that I want to run. So this is a Granite model augmented with InstructLab. So I can run this, so you can create model service. And since I've already run it before, I can just start it right here. So you can see model services. And I'm going to go ahead and start that. So I'm going to add even more load on my machine. So hopefully that'll go well. And in a moment, this model service will be up and running. And now I can play around with it on my local machine. So I have another Quarkus application that's using LangChain4j, which allows me to interact with models. So in this case, you can see localhost 35,000. Let's make sure that this is the port that I'm exposing here. Yes, 35,000. And so when you run a model service with Podman desktop, you can also get some handy little scraps of code here to interact with the model. So you can see here client code, and so we could make curl commands directly to this model. You can also, if you're a Ruby developer, a Python developer, or PowerShell or whatever, you can generate some code to interact with this model. So in this case, if we want to use Java, we have the option between using OKHTTP, HTTP, Unirest, and Quarkus LangChain4j, which is what I'm using. And look at that. It even generates what I would need to add to my application to interact with this model. So that's pretty cool, which is what I've already done in my application, right? So I'm going to go back to here. So you can see I'm pointing to localhost 35,000, which is where the model is running. I'm using the model InstructLab Granite 7B, and then I have this assistant. So basically with LangChain4j and Quarkus, you do this register AI service, and then you can set some context. So I'm going to tell the model, hey, act as if you are a Java developer who likes to over-engineer things, just kind of a funny little way of generating some code. And then you can pass it a message to generate something. So then I have a REST endpoint with my prompt. And you can see here, there's a message that I'm going to pass to the model that says, generate a class that returns the square root of a given number. So, just some idea of something that I wanted to create. So let's run our Quarkus application on our local machine with Quarkus dev. And we'll see that in a second. It'll start up the application if I don't run out of resources on my local machine. And then we can see if it'll generate our code from the Java developer who likes to over-engineer things perspective, right? So let's give it just a moment to start up. Okay, everything is going well. And drum rolls. Okay, looks like we need one more second. Okay, so let's go to localhost 8080 where my application is running. And then that should call my model server, my inference server that's running on Podman desktop. So you see that this does take a little while, right? Because this is all running on my local machine and AI is pretty resource hungry. I don't have any GPUs running on my local machine. So this takes a little while. If you do have GPUs on your local machine, Podman desktop does not support them at the moment, but that's something that's coming very soon, FYI. So we'll let that run for just a moment, and then I'll look in our chat and see if there are any questions. So I can see that Pascal asked, when you create a Podman GUI, is there a handy way to get the result out of it? Is actually. So you can make a cube YAML for your directly from Pod.
Hello, Kevin. I'm not
And
sure this
desktop.
is just me
I'm
myself, but yeah, you.
Q&A. There might be some questions as well. Yes.
Oh. Yeah.
No questions?
Hello, Kevin. I think yeah. So you were broken, so I think we couldn't. Yeah. So
Yeah.
can you just say it again for this question? Thank you. No. Yes.
Yes. Sorry. Can you hear me well now? Okay, good. Yeah, sorry. So yeah, I was afraid that was going to happen with using so many resources on my local machine. So I turned my camera off. Hopefully that helps too. So to answer the question again, so you can generate YAML from your resources in Podman desktop as well. Yes. So if everything works well here. So you can see here for this particular container, for example, generate cube. And now you can see that.
Yeah.
It generated the YAML for that resource.
Hello.
From Podman desktop. Thank you again.
Yeah.
The answer is yes.
Yeah.
Okay, so okay, so in the meantime, I'm going to stop my inference server. So hopefully that'll help with my resources and make the sound a little bit better. And I do want to show that in the browser, it did generate our code, right? So you can see here that our model responded with, here's a Java class that calculates the square root of a given number. And it definitely did kind of over-engineer the answer, right? So I think we had a successful answer, even though it did use quite a bit of resources on my machine. But you can see that that's pretty cool that with Podman desktop we can also run AI stuff. So I want to show one more cool thing here in Podman AI Lab. So you also have this recipe catalog. Where you can, for example, start a chatbot, object detection, create audio to text, summarize your text, And so you can use open source models running on your local machine to do this. And it'll show a recipe of exactly how you can do this, and even how to download and build these model services. So it gives you, you know, as you're learning about AI models, a lot of really interesting information. So that's pretty cool as well. And then in the playgrounds, you could also interact with models running on your machine as well. So here I can create a playground again for my instruct lab, and then I hope that my sound is not going to get all crackly again. But then you could, for example, play around with a model, and you can play around with different temperatures and tokens and top P values, and learn about, you know, like you want to try a model and see, you know, like if I set the temperature to higher, then it's going to be more creative about what it answers. And if you set the temperature to lower, it's going to be more deterministic. So you can play around with your models as well directly from Podman Desktop and Podman AI Lab. So that was, you know, a quick introduction of Podman and Podman Desktop. So today I focused mostly on Podman Desktop because I think, you know, there's a lot of really cool features. But yeah, if you are more into the CLI, you can of course use Podman, the Podman CLI as well. So to finish it up, and if you have any questions, definitely post them, and then I'll try to answer them as well. So if you want to get started with Podman and Podman Desktop, I would recommend just going to podmandesktop.io, and it'll guide you through installing Podman itself. You can also, of course, it's an open source project, so if you have any issues, if you see any missing features, definitely let the project know. You know, it's a community project. You can contribute, of course, yourself as well, and you can be involved in the community. And yeah, so we looked at Podman Desktop and Podman AI Lab, so hopefully this piqued your interest as well. And I didn't go into too much detail about Instruct Lab, but you know, it's definitely a really cool project if you would like to get started with you know, training an AI model without, you know, like immediately being a data scientist and an expert. This is an easy way you could just generate some YAMLs. And then, yeah, so there are extensions for Podman Desktop supplied by Red Hat, but yeah. If you want to learn more about, you know, the difference between Docker and Podman, there's some resources on YouTube as well. One of them is by my fantastic colleague Cedric, who you know, created a video about that, and then Christian here, who is, you know, somebody that also pitted Docker against Podman, so you can look at that video as well. And that's about it. So I'm going to look and see in the chat if there are any other questions.
Yeah, there is one more question in the Q&A function.
Okay. So let's take a look. Q&A. Can the Podman CLI also generate YAML for pods ready for deployment on Kubernetes? I believe so, but I'm not entirely sure. So we'll have to look that up, but I believe so. Any other questions? Going once, going twice, sold, and we're right at the top of the hour.
Perfect. So